So you're building something for the Internet of Things, and you know the message broker is the absolute heart of your entire system. Get it right, and everything just flows. But get it wrong, and, well, you're looking at total chaos. Today, we're going to dive deep into the top open-source MQTT brokers out there to give you the clarity you need to pick the perfect one for your project.
First things first, let's just talk about the sheer scale we're dealing with. By 2030, analysts are predicting there will be over 100 billion, that's billion with a B, connected IoT devices. Think about that. That's more than 10 devices for every single person on Earth. The scale is almost impossible to wrap your head around.
And that brings us to the central challenge, right? How are all of these things, from tiny little sensors to entire connected cars, going to communicate with each other reliably and efficiently? They all need a common language and a really robust system to manage all that chatter.
To figure that out, here's our game plan. We'll kick things off by explaining what an MQTT broker actually is. Then, we'll meet the top players in the game, put them head-to-head in a scalability showdown, compare their key features, and then finally, we'll build a super simple framework to help you choose the right one for your project. Let's do it. All right, let's start with the basics. What exactly is an MQTT broker? You know, the best way to think about it is as the central nervous system for your entire IoT setup. And the language this nervous system speaks? It's called MQTT. It's an incredibly lightweight messaging protocol, which is exactly why it's become the gold standard for IoT. The whole thing is designed to send tiny, efficient packets of data super reliably, without killing batteries or clogging up networks. And the broker? Well, that's the brain of the operation. It's the central hub, kind of like an air traffic controller, that takes in every single message from every device and then smartly routes it to exactly where it needs to go. Seriously, without a broker, you just have a mess of devices all shouting into the void. Okay, so now that we're all on the same page about what we're talking about, let's meet the main contenders in the open source world as we head into 2025.
You know, this table tells a really interesting story about the community behind these projects. You can see EMQX leading the pack with over 15,000 GitHub stars. That's a huge sign of developer love. Then you've got Mosquitto, the veteran in the room, around since 2009 with a massive established user base. And check out NanoMQ, a relative newcomer from 2020 that's already showing some serious activity with thousands of commits. Now, you see LavinMQ on here, but it's worth noting its development has kind of slowed down recently. So for our deep dive, we're going to focus on the other three.
Having a strong community is awesome, but let's be real. In the IoT world, it's performance under pressure that really, truly matters. And that brings us to the scalability showdown. This is where we separate the brokers that can run a smart home from the ones that can run a smart city.
And whoa, the performance gap here is just staggering. On a single server, EMQX can handle up to 2 million messages per second. Just look at that bar compared to the others. NanoMQ is also pretty strong at 500,000, while Mosquitto's single-threaded design tops out around 120,000. Now that's perfectly fine for a lot of projects, but if you're doing anything with high throughput, the difference is just night and day.
But what if you need to go even bigger? This number right here. This is the proven number of concurrent connections a single EMQX cluster can handle. 100 million. Let that sink in for a second. We are talking about connecting every single device in an entire country through one logical system. This is what true hyperscale IoT looks like.
So how in the world does it do that? Well, the magic word is clustering. EMQX is built so you can link over 20 servers, or nodes, together so they act like one giant, super resilient broker. This is absolutely critical for both massive scale and for making sure there's no single point of failure. In contrast, Mosquitto and NanoMQ are designed as powerful but single-instance brokers. That makes them simpler to set up for sure, but it also limits their ability to scale out for those truly enormous, mission-critical deployments. Okay, so raw speed is key, but a modern broker does a lot more than just pass messages around. We've got to look at the features, the security, and the integrations that can literally make or break a project. And here, the differences get even clearer. Both EMQX and NanoMQ are pushing the envelope with MQTT over QUIC, which is a newer protocol that works way better on shaky networks like cell service. But EMQX just layers on a bunch of enterprise-grade features. For example, it has a built-in SQL engine that lets you process and filter data right inside the broker itself before it even touches your database. I mean, that is a total game changer for operations. And this right here is a huge one.
Data integration. Getting your IoT data into other systems, like Kafka or a database, is pretty much always the next step. With EMQX, a lot of that is built in, out of the box. For Mosquitto and NanoMQ, you have to write that integration code yourself. That's the difference between a simple configuration and, a whole separate development project.
Okay, we've seen the specs, we've seen the features. Now for the most important part. How do you take all of this and make the right choice for your specific needs? Let's keep it really simple. Just ask yourself these 3 questions. First, what's your scale? Not just today, but 5 years from now. Second, what features do you really need? Do you need that data integration? And third, where is this thing actually going to run? The answers to these questions are going to point you straight to the right solution.
So if your answer to question 1 was massive scale, then you're definitely looking at EMQX. It was just built from the ground up for those huge mission-critical cloud deployments. But if your answer was more like simplicity and a small footprint, especially on a device with limited memory or power, then Mosquitto is a fantastic, proven, and really straightforward choice.
Now let's think about the environment. If you're deploying on an edge gateway out in the field, NanoMQ is a brilliant choice. It's lightweight, but its multi-threaded design gives it great performance, and, this is cool, it can act as a bridge to other protocols you often find in industrial settings. But for the big, central cloud platform that's pulling in data from all those edge devices, you're right back in EMQX territory. And finally, it's worth asking, is a specialized IoT broker always the right tool for the job? I mean, EMQX is laser-focused on IoT with deep support for all the related protocols. But what if your needs are broader? Just for some context, let's look at something a little different, like LavinMQ. It's a general-purpose message broker that supports MQTT, sure, but also other protocols like AMQP. It's a different tool for a different kind of job, which just goes to show how important it is to match the broker's specialty to what your project really needs. Ultimately, what all this really shows is that MQTT isn't just another protocol. It's truly becoming the nervous system of our connected world. The broker you choose is the brain of that system, and its capabilities are going to define everything your network can possibly achieve.
So, as you go to start your next project, the question isn't just, which broker should I download? It's this: with 100 billion devices about to come online, what kind of nervous system are you going to architect for our connected future? Thanks so much for joining us for this explainer.